And so in this video, I will go through the process of making the explosion in Houdini. So just to show the demo how it works is um, if we take a sphere or any geometry and if we connect the pyro source node here, so it will convert the geometry into all these points. And since we have these points, uh, we can set the attributes. We have two attributes. One is the density, and another we have is the temperature. We can set it here. We have different uh, attributes as well, like velocity, fuel, burn. But we can set we'll set this to density and temperature. And then once we have these points, what we can do is we can use volume rasterize attribute, which will convert all these points into voxel. And voxels are nothing but like a 3D pixel that covers this whole area. And so in this volume rasterize attribute, we'll add two attributes, density and temperature, that we create here, density and temperature. So once we add this here, we need to set the voxel size, like how big we want the voxel or how small we want them. And once we get this, we want to add this volume rasterized attributes to the DOPNet. So we'll use this DOPNet node, and once we open it, uh, we only have this output, this DOPNet. So what we'll use is we'll use a smoke solver and connect it to output. So we have, and if we only output this and play it. Oh, it's playing it because I have cached the thing. Yeah. So right now it's not playing anything because we don't have anything in the smoke solver. So then we need two nodes. One is volume source from where we want this um uh from where we want the source from for the simulation, and we'll use volume source node and connect it to the force. And once we have this, we will select input to first geometry context, which is, if we go back, it is this first one in the DOPNet. So whatever we connected in the first one, it will use this as a source. So this is the source of the um, pyro solver, and we will use smoke object sparse to store this source volume into uh, for the simulation. We will connect this to the first one. And if we see it here, we have something like smoke going on, which just like this. And so we have different attributes here. So if we go here, uh, we have different visualizer here. So if we come here, we can set the voxel size to whatever we want. The smaller one will give the more crisp result, but bigger one will not give good result, but it will be fast to simulate. So yeah, and in here we will go to volume and we will add two different attributes. The one is density and temperature, which is we created before. And since we have these two, we can just come here and uh, we can set the temp. We can see the temperature field, and we can see the density. If we click on multi-field, we need to turn on the multi-field because there isn't anything in the multi-field. But if we set density into the multi-field, we can see if we set it to set it here, we will be able to see. No, right, yeah. But yeah, we can add different fields to visualize this. Um, and with here we can use gas turbulence and gas disturb, which are the nodes that we can use to make the some turbulence or noise. Because right now it's just the smoke that is going upwards. So if we connect this here, gas turbulence, and we set the turbulence value, you can see that we have some turbulence going on. If we connect gas disturb as well, we have more disturbance in the smoke, and we can play around with the different settings. So this is how Houdini renders the no, not renders. This is how Houdini simulates the fire. No, but for this explosion, we'll use this. I use this pyro burst source, which is just the combination of these two things, because now we don't need to create a shape and then make convert them into point and then make a um, voxel, because we already have this one. So if I turn on this and if we come here, here I want this explosion to be look more like. So the reason it's showing this type of thing is because uh, in this one we have density, temperature, burn, and velocity, all four attributes here. It's just a visualizer. So yeah, so here if we go to pyrobus source, we can set the different we can set shape offset. This is initial size. We can set the spread angle, and we can change the length. So right now I used muzzle flash instead of explosion because I want it to be look more like this type of spiky explosion. And if I show the some references, so, so in this one it's more like round, but I wanted to look more like spiky explosion, something like this maybe. Uh, so I use the muzzle flash, but explosion gives really good result as well, but it will be more like rounded. And so I used muzzle flash, and then we can change number of trailings, and we have all these parameters that we can change. So I set the frame duration to 30, so it will scale up to 30 frames, and then it will stop. But for this 30 frame, we could use this to start the simulation. And once we have this pyro burst source, we will connect this to the volume rasterize attribute, and here we will add the attributes of density, temperature, burn, and velocity. Once we have this, we'll do the same thing, but like here, if I disconnect this thing, now we have pyro solver, we have volume source, and we have smoke object sparse. So this is the source which is using the first context geometry, which is this part. And then here we will add um, all the attributes that we added before. So we have density, we have temperature, and here I have used, I have had another one. The source volume would be burned, but uh, the target frame, I used it as a divergence, because this divergence will make it more like it will make it more it will make the simulation to expand more, and we can set the scale to really big so it can expand more over time. And then there is a burn and flame. So source volume would be burned, but the target would I set to flame. So the target is the flame, which basically means that which is how hot the fire and the explosion is, and it is more like the temperature field, but but the flame sets more like intensity of the fire, where temperature sets more the color of the explosion and fire. So yeah, so we have these four, um, source volume and target field. So once we have this, we'll connect this to smoke object sparse, and here we have in the smoke we will use density, and in the emission, instead of burn we will use temperature, because I tried with burn, and but the temperature give like good result than the burn, so I used this one. So now once we have this, we'll go to pyro solver, and here we have time scale. So this is like how long we want the simulation to be. If it's bigger scale, it will keep on going before it actually disappears. And in the flame, it's flame lifespan. So how long we want the flame to turn into smoke. So if we set it to lower value, the flame will be disappear in less time, and then it will turn into smoke. And this buoyancy scale, which means that how fluid it would be, and um, how it will float in the air, how intense it will be floating in the air. If we set it too high, it will go up in the air really fast. And this is the cooling rate, how fast the simulation will cool down and disappear. Yeah. So now we have this. And then what I did here is we need to, so if I play this, yeah, this will show the explosion. Yeah. And if we go to visualization, you can see we have multi-field, which in multi-field I have set the density, and in MSU we have temperature. So if I turn on only density, you can only see the density. If we see the temperature, we have this visualizer. We have velocity here as well. We have flame as well. So these are just a visualization. But yeah, if we set it to multi-field, we can. It doesn't look like more fiery explosion, but it's just for the visualization. And then we'll use gas disturb, which will make how much the disturbance we want in the gas. And this gas shred, how much we want the gas to be like torn apart. And there is the turbulence, how much turbulence we want in the simulation. So I used these three nodes and merged it with the merge node and just connected over here. And I played around with all these settings, and then I I got the desired result by playing around with different settings and trying out the different simulations. And then it looks like this. And for the turbulence, I added the keyframe from where if I set here the turbulence is 0.50, but after that we want the turbulence to be 0. So I set the keyframe to 0.15 to then 0 in 100 or something frame. And once we have this simulation, if I go back and we have this um, simulation stored here. So what we'll do is we can use drop import field, and once we have this, we'll just drag and drop this into over here, and then we can click here and use the smoke object sparse. And once we have this thing, we can use pyro post process node, and here we can set the voxel size. And once we have this, we can connect it to the pyrobake volume. But before we make the pyrobake volume and add color and all the visual thing, we have to cache out the simulation. So I use the cache file cache node, and then cache out this whole simulation into this location. And we can set the start and end keyframe, start and end frames. And yes, and then once we cache out this simulation, we have this. By the way, I had to do so many different simulations and and change the values of so many different parameters to get this result. So it was more like back and forth and simulating again and again. Once we have this, I use the pyrobake volume, and then I use the time shift node to make the simulation faster in the beginning. So it's more like fast explosion and then it slows down. So for the pyrobic volume, for the smoke, I set the density to 5 and set the smoke color to this gray and uh, set the shadow color to 1. And in the scatter, I changed this gradient and made it more dark, more red, and set the intensity scale to 60. And in the fire, I set the intensity scale to 20. And yeah, if we see the simulation, it looks like this. And once we have this simulation, what I did here is then I went back and set the camera. So yeah, I set this camera over here. So from this angle, it looks like this and it covers the whole area. And since I'm going to render it in 8 by 8 grid flipbook, so it would be 64 frames. So I made sure that my whole simulation will last till 64 frames. And once we have this, we'll change to build to games. And here in the output, we will use the flipbook flipbook labs flipbook texture node and then export them on the selected resolution. So if I want the each frame to be 1K, it will be 1024 by 1024. So 8 by 8 would be 8K. Similar to if I set it to 512 by 512 and 8 by 8, it will be 4K resolution. And here we can drag and drop the camera and we can drag and drop the pyrobic volume. So once we drag and drop it, it will change it will set the source and the source for the pyrobic and camera input, and then we can just set the name uh, and the extension and here, and then we can just click on render and it will export the whole flipbook animation. So same way I made the different explosions. So first is this one, which is more spiky one, and the another one is this one. I need to cache out this simulation to view it. And then I have this simulation, which is the pillar one. And I have another one, which is this smoke puff. Right now it has all these flames, but if we go to pyrobic volume, we can turn down the fire so there is no flame, it's just smoke. And yeah, I have this falling smoke in it. So I then I rendered out 1, 2, 3, 4, 5. These are these six flip books, and then if you see here, mm, we have all these flip books. So this is the explosion on the ground. This is explosion on the air. This is falling smoke, and this is another explosion which will be used in the bullet shooting. And these are the pillars. I think this is the high-res one. Yeah, and this is the smoke puff. So I rendered out all these flipbooks and used them into the mm, Niagara particle system. So this is the explosion. This is the pillars. These are all individual pillars, and this spawn randomly in the certain um, spherical shape. And this explosion. So that there is problem with the explosion is that it has watermark for some reason. But yeah, and once we combine all of these things into one, it looks more like this as well. So yeah, these the I made all these other ones is just like the way I make this, but I had to tweak so many different settings for each one, and then I made all of them. So yeah.